Good morning. Laurent's theorem lesson 2 assignment. First example, prove that cos hyperbolic z plus 1 over z is equal to a naught plus infinite summation which starts from n equal to 1 on an into z the power n plus 1 over z the power n, where an is equal to 1 over 2 pi integration from 0 to 2 pi on cos of n theta cos hyperbolic 2 cos theta d theta. This we have to prove. Alright. For the solution, we just have to repeat the same steps, the steps we have done in the previous examples. Since cos hyperbolic z plus 1 over z is analytic everywhere except z equal to 0 and z equal to infinity, because at these points the function is not defined. So this function cos hyperbolic z plus 1 over z is analytic in the NLS, let's say, mod z lying between, which is greater than equal to small r and less than equal to capital R, which is further less than infinity, and your small r is positive, where r is small and capital R is large. Now if this is analytic in this NLS, I say that this function is also analytic in NLS lying between small r and capital R. So fz can be expanded in the Laurent series in the NLS mod z lying between small r and capital R. So we have to use Laurent's theorem here. So hence by Laurent's theorem, the given function is equal to summation where n starts from minus infinity to infinity a n z the power n. So the given function is represented as this, which is equal to summation going from 0 to infinity a n z the power n plus summation n going from 1 to infinity a minus n z the power minus n. If you put the values, if you open this sum, you will get all those terms if you open this summation. This is one and the same thing. Further, this is equal to, I put a minus n to be as bn, right? Where your an is equal to, according to the Laurent theorem, this is 1 over 2 pi iota integration over c cos hyperbolic, that is your function z plus 1 over z dz over z the power n plus 1, right? So according to Laurent's theorem, the coefficient is equal to this, and we have taken bn to be equal to a minus n, and having our first circle to be centered at 0 having the radius 1, right? We take these three, and now putting the values of z in the polar form in an coefficient, right? So let's write 1 over 2 pi iota integral over, which starts from 0 to 2 pi cos hyperbolic. Now instead of z I would write e the power iota theta in polar form plus 1 over z can be written as z inverse, which is e the power minus iota theta into, and dz is, you have to put z is equal to e the power iota theta, and in that you get dz to be equal to iota e the power iota theta d theta. So my dz is iota e the power iota theta d theta over z the power n plus 1. So e the power n plus 1 iota theta. Fine. This is equal to 1 over 2 pi iota integration from 0 to 2 pi cos hyperbolic. Now e the power iota theta plus e the power minus iota theta is nothing but 2 cos theta. This is your formula, and on cancelling we get e the power minus iota n theta d theta. So this is equal to 1 over 2 pi iota integration from 0 to 2 pi cos hyperbolic 2 cos theta, and now opening this, e to the power minus iota n theta will be cos of n theta minus iota sine of n theta d theta, right? Now separating this integral, I will get 1 over 2 pi integration from 0 to 2 pi. Wait, in the second step, I cancel this iota with this iota, right? So now iota is not coming here. This is only 2 pi. So this is equal to cos hyperbolic 2 cos theta cos of n theta d theta minus iota over 2 pi integral 0 to 2 pi cos hyperbolic 2 cos theta into sine of n theta d theta. I need to prove this integral, second one, to be equal to 0. For that, I will be using the remark that if f of a minus z is equal to minus of f of z, then the integration from 0 to a f of z is equal to 0. Right? This is our remark. So let's check the second integral. This comes out to be 0. I will explain. So this is 1 over 2 pi integration 0 to 2 pi cos hyperbolic 2 cos theta cos of n theta d theta. This is 0. See, if you check your f of 2 pi minus a, I will explain how this is 0. This is your function, right? See, cos hyperbolic 2 cos. Now instead of theta, let's check for 2 pi minus theta. So instead of theta, just check for 2 pi minus theta sine of n 2 pi minus theta. This comes out to be equal to cos hyperbolic. Now 2. Cos of 2 pi minus theta is minus cos theta, right? And sine n 2 pi minus theta is simple sine of n theta, right? So this is equal to nothing but minus of this given function which is present in the second integral, right? This is the negative of just which integration is there? Yes. So hence, because f of 2 pi minus z is equal to minus of f of z, or f of 2 pi minus theta is equal to minus of f of theta, hence this integration is 0. So this integration comes out to be 0. And we are left up with 1 over 2 pi as the value for an, 0 to 2 pi cos hyperbolic 2 cos theta cos of n theta d theta. Is it fine? Is it fine? I write this remark at here. 0 to a f of z dz is equal to 0. if f of a minus z is equal to minus f of z. Here your z is representing as theta variable and a is 2 pi, right? Check this result and get the second integral to be equal to 0. Now what for bn? Bn is a minus n. So this is equal to 1 over 2 pi, 0 to 2 pi, put minus n in place of n. Cos of minus n theta cos hyperbolic 2 cos theta d theta, which is equal to 1 over 2 pi integral 0 to 2 pi. Now cos of minus theta is cos theta. So this is cos of n theta cos hyperbolic 2 cos theta d theta, which is nothing but again your an. So cos of minus theta is equal to cos of theta. So putting bn is equal to an and 1, we get, you can also use as cos of minus n theta, which is equal to cos of n theta. Putting the values of bn is equal to an and 1, we get cos z plus 1 over z is equal to infinite sum an z the power n plus infinite sum which starts from 1. Instead of bn, I put an here because both the values are equal, z the power minus n. Now I need here first term to be a0, a0, right? So I just put n equal to 0 and write my first term. So this is, when I put n equal to 0, z the power 0 will become 1. So this is a0 plus, now my summation will start from 1 to infinity. Which is an z the power n plus this summation 1 to infinity an z the power minus n. I have to sum up this. So this is equal to an plus summation taking common because summation start from n equal to 1, an z the power n plus z the power minus n. This is equal to, this is a0. This is equal to a0 plus summation n going from 1 to infinity an z the power n plus, instead of z the power minus n, I can write 1 over z the power n, where this coefficient an we have proved this is 1 over 2 pi 0 to 2 pi cos of n theta cos hyperbolic 2 cos theta d theta, hence the result. Fine. Alright, the next example, show that e the power 1 by 2 into c into z minus 1 over z is equal to summation n going from minus infinity to infinity an z the power n, where an is equal to 1 over 2 pi integral 0 to 2 pi cos n theta minus c sin theta d theta. This we need to prove. Now for the solution, the given function is analytic everywhere except z equal to 0 and z equal to infinity. So therefore this function is analytic in the annulus mod z lying between, yes, which is greater than equal to small r and less than equal to capital R, which is further less than infinity, and small r is positive, where r is small and capital R is large. So fz can be expanded in the Laurent series in the annulus z lying between small r and capital R. So by the Laurent's theorem, we have this function to be equal to n going from minus infinity to infinity, this sum an z the power n. Now we need not separate this in two sums other because we need only this. Where an is equal to 1 over 2 pi iota integration over c1, your function fz, then dz over z the power n plus 1, and I have to take my first circle to be centered at 0 with radius 1. Now again I put the value of z is equal to e the power iota theta, which is in polar form, and dz comes out to be iota e the power iota theta d theta. So just right now, this is 1 over 2 pi iota integral over c1 e the power 1 by 2 c, instead of z write e the power iota theta, plus 1 over z can be written as z inverse, which is e the power minus iota theta, into this dz, which is iota e the power iota theta d theta over z the power n plus 1. So e the power n plus 1 iota theta, right? So this is equal to iota iota cancel, so this is 1 over 2 pi integration. Now this is my circle C1, so I have to put the limits in theta, so which is from 0 to 2 pi, as it is a circle, e the power 1 by 2 c. This is now e the power iota theta plus e the power, sorry, here the sign is, you are having, wait, in the question I'm having z minus 1 over z. So by mistake I write plus sign here. I'm very sorry for that. This is minus. So this is equal to, this is your z minus 1 over z, and here also put z minus 1 over z. So in the next page, here also we have to put z minus 1 over z, and this will be e the power iota theta minus e the power minus iota theta, right? Now the formula for this is e the power iota theta minus e the power minus iota theta is equal to 2 iota sine of theta. When positive sign is present, we write it as 2 cos theta. When negative sign is present, the formula is 2 iota sine theta into e the power minus iota n theta d theta. This, when you cancel out the powers, you will get this, which is equal to 1 over 2 pi integration from 0 to 2 pi. This is e raised to the power iota e c, iota c sine of theta into e raised to the power minus iota n theta d theta. 2 cancel, right? So this is equal to, if you add the powers, so this will be 1 over 2 pi 0 to 2 pi e raised to the power, take iota common, and this will be c sine of theta minus n theta. D theta, right? Now we use, suppose if this is your whole theta, right? Take this any other variable, let's say this t, e the power iota t, then this will be cos of t plus iota sine of t, right? So your t is c sine theta minus n theta, right? So let's open this. An is equal to 1 over 2 pi integration from 0 to 2 pi cos of c sine theta minus n theta d theta plus iota sine c sine theta minus n theta. I open that and separate the integrals. Can I write this step here? This is nothing but 1 over 2 pi integration 0 to 2 pi. Yes, you just have to write the formula for e the power iota this whole t, which will cos of t, that is c sine of theta minus n theta plus iota sine of c sine theta minus n theta d theta. Separate this integral, right? Now I get the result as the first integral. I need to prove second integral to be equal to 0 for the desired result. Now how the second integral is equal to 0? We have to just check f of 2 pi minus theta is equal to minus f theta. This we need to check. What is your f theta? The given integral, that is sine c sine theta minus n theta. If I solve f of 2 pi minus theta, this will be equal to minus f theta. If this happens, then the second integral is 0. Again, you have to remember your remark. So let me check f of 2 pi minus theta, which is equal to sine of c sine 2 pi minus theta minus n 2 pi minus theta. So this is sine of c. What is sine 2 pi minus theta? It is yes, minus c sine theta. Very good. Because it is in the fourth quadrant, and in the fourth quadrant sine is negative. Minus 2n pi plus n theta. Right? So this is equal to sine of, I'm taking a minus as common, 2n pi plus c sine of theta minus n theta. Now sine of minus theta is minus sine theta. This you know. See, cos of minus n theta is cos of n theta, and sine of minus n theta is minus sine of n theta. Whether you are having n or not, that doesn't matter. I can write the formula as simple. If you have cos of minus theta, this will be cos of theta. If you have sine of minus theta, this will be minus sine of theta. So here I am having sine of minus this whole angle, right? So this will be minus of sine this whole one. Is it clear? So I am taking this to be as minus of sine 2n pi plus c sine theta minus n theta. Further, this is equal to minus sine, yes. Now here I am having 2n pi plus some angle. Now what is sine 2n pi plus some angle? That is the angle. See, sine of 2n pi plus any angle theta is equal to sine of theta, right? So if I see sine of minus sine 2n pi plus, this should be any angle suppose, then that will be sine of this angle. So this is c sine of theta minus n theta, right? So which is equal to minus, this is nothing but your f theta. So f of 2 pi minus theta comes out to be minus f theta. Hence, the second integral is 0. So this whole integral is 0. We have used two results. One is this and one is this. So substituting 2 in 1, we get this. Substituting 2 in this one, we get only the first integral, second is 0. So an is equal to 1 over 2 pi integration 0 to 2 pi cos c sine theta minus n theta d theta, which is equal to 1 over 2 pi integration 0 to 2 pi cos n theta minus c sine theta d theta. Again, I took the minus sign common and write cos of minus theta to be equal to cos of theta, because I need n theta to be positive. Hence, the given function is equal to summation n going from minus infinity to infinity a n z the power n, where this coefficient is proved to be equal to 1 over 2 pi integration 0 to 2 pi cos n theta minus c sin theta d theta. That's why cos having a very nice property, that is cos of minus theta is equal to cos of theta. So we have get our result. Thank you. We will meet in the next video and we'll be doing some more examples, and also next one is your Cauchy residue theorem, some more theorems. So thank you all of you.